Hello everyone, this is Billy. This is the last part 5 of the videos that I show you how to use 3D printed design to create the FM crystal radio. If you want to support my work, there's a PayPal link in the description that you can click to contribute a small amount of money, or you can click the Patreon account link to have a monthly subscription. Also, there's an Amazon link that I've provided for the components you may need to create this FM crystal radio. If you click through those links to make the purchase, Amazon will just give me a tiny bit of money to support my work, but you won't get a price increase. It will be always the same price. Hope you can choose one of those options to support my work. In this video, we will go through how to download and print it, in particular how to split it up to print different components one by one. Then we'll have the physical build. I will start from scratch and build up this FM crystal radio. And finally, we'll test it in-house and on the street. All the links to my files are in the description of the YouTube. You can go there. It will have a link to my blog, and then you can find the rest of the links from my blog. So let's start Cura now. You can download Cura from their official site. So once you are in Cura, go to File, Open File, and then just go to the file that you have downloaded. So I've created multiple versions of the 3D file. There are basically 4 versions. The first one is the fixed plate, 2 fixed plates, and with the copper plate of 0.5 millimeter thick. So if you have some copper plates of 0.3 millimeter or even thinner than that, choose this file. And then there's another file called 2 fixed plates 0.8 millimeter for copper plates of 0.8 millimeter or above. So if you're using that, just choose this file. So this is the original design to use 2 fixed plates held together by screws. I find it looks nicer, looks better. However, the Q factor is a bit lower than this new design, which is using a single plate of copper that we fold in half to create the variable capacitor. Again, we have a 0.5 millimeter version and 0.8 millimeter version. So let me show you using this 2 fixed plate 1.5 millimeter version. Let's open. Once you open, you will see all the parts listed here, shown on the printer board. You can right-click your mouse and move your mouse across to view different angles, even the bottom. Some of you asked me how to split this up and only print certain components. So there's a feature called Split Parts in Cura, but you first have to download the add-on first. So go to the marketplace here, click on it, and then go to plugin. It will come up with some suggestion. And then go to Mesh Tools. I already downloaded it, so it's already checked, but you can click Install again to install it. Once you install it, just quit Cura and open it again to include that new plugin. And then open the file again. Then you can right click on any parts. And then you see on the screen Mesh Tool. And then there's a option to split model into parts. So it will go through the model. Whenever the 2 parts are separated by a gap, it will break it out into multiple different models. Let's click this and see what happens. So you see here, it's running and splitting up into multiple parts. 1, 2, 3, 4, 5, 6. So many parts. So if you can now manipulate individual parts one by one, or you can move them, or you can remove them. For example, if we already printed the baseboard, we can right-click and remove the baseboard, delete the selector model, remove it. Then we can just print this other component. If you want to just print one component, you can just move it out and then highlight. Oh, you can't highlight. You can use the Shift key to highlight all the components you don't want while holding the Shift key. Just delete selector models, and then it will delete everything you highlighted. Then you can move your component back to the middle to be printed. So this is how you can print one component. So assuming that you want to print everything, we'll just reload the component again. Reload all model. So we'll bring it back to the state when we first open the file. And if you see, I click on the model, there's only one model, and if I move it, the entire group of model or parts will be moved because we haven't split it into parts. Okay. So I've designed all this STL file so it will fit on your print bed. I'm using Creality Ender 3 Pro. If you like this printer, don't buy the old one, buy the Creality Ender 3 version 2, which is much better, much quieter. If you like that, click on the Amazon link in my description. It will bring you there so you can buy the printer and also support me. So once you finish setting, you have to go to here to change the infill from the default of 20 to 50%. Then you can come here to check that support is blank because we don't need to print support, so we need to blank it out. Once you are done, you can see it here. Infill is 50%, support is off. Then you can click Slice to convert the 3D file into the G-code file which is used by the printer. Okay, once you finish that part, click Preview. The preview will allow you to look at the different components as it went through the printing, right? So let's use the vertical sliding bar at the far right to slide it to layer 1. So this is layer 1. We need to make sure in layer 1 every part at least got something printed. Otherwise it will be floating in the air and it will not be printed nicely because there's a gap in the space. Okay, and then you can also flip to the bottom and see whether the bottom is fine. The engraving is printed with your name and things like that. Okay, and then you can move it up, move to the last layer, and then you can check it out again. This is to simulate that the printing is complete. You can check out all the holes that we drilled during the design phase, whether they're all drilled through, whether you see the holes there, and whether there's any defect. If you are fine with it, click Save to removable drive. So I use a removable drive like this, Ender 3. This is the previous file, so I move it to bin where there's nothing there. Then now we can click on the Save to removable drive, and then we can check, oh, it's actually one more file is created now. This is the G-code file that we can use to print. Then after that we can click Eject, and the SD card has been ejected from your computer, and you can use the SD card, insert it into the 3D printer, and then start printing. The printing time, you will be able to check here, 6 hours, 23 minutes. But depending on the printer, this is just the estimation. Sometimes it takes longer, sometimes shorter, depending on your printer. So after waiting for 6.5 hours, finally the printer finished printing. I use a single color to print all the parts, but if you like, you can print the baseboard in one color and the other component in a different color. Show you how to make the two different versions of my design. The first version is the fixed plates, and the second version is the folded plates. The latter will have a better result in terms of reception. If you need to buy the copper plates, you can follow the links in my description. Go to Amazon to buy it there. After printing, we need to pick the mock-up plate for the fixed plates and then mark it on the copper plate. For this one, I'm using the fixed plate version and using a 0.8mm copper plate. So depending on the thickness of the copper plate, you need to print the right version for you to create this mock-up. So draw out all the shape, outline it on your copper plate. Make sure the marks are dark enough for you to see. Next step is to mark the holes on the copper plate using the mock-up, so you can drill the holes at the exact position afterwards. And you can cut out the fixed plates according to the marks. And use a pile to smoothen out the parts so it won't block the rotation of the plate. Then we drill the holes that we marked earlier on and make sure we drill at the exact position. We install the two fixed plates with the upper bar attached in between. And then we put the lower bar on the baseboard and mount the moving plates and the fixed plates in position using the M3 screws. If you want to build the version with the folder plate, then you need to print out that 3D print file with the folder plate. Follow what we did before, mark outline the shapes on the copper plates. This time we're using 0.5mm copper plates because otherwise if it's too thick, you can't fold it in half. After cutting, it's always good to hammer and make it flat before we drill holes and do other things. So we have drilled the holes and now we need to mount it on the spur gear. Using the M3 screw, we can drill through the baseboard and put these rotating plates in the right place. We're almost done. We just need to install the second gear, which is the knob. You can use the M3 screws and drill through it from the bottom. Fix the plate that is folding, we need to cut out this mock-up plate, which have two fixed plates in one position, and you have the middle slot there, that is the place where you need to do the folding. So you need to mark it clearly. You also need to mark the place where you are drilling the holes. Cut out the parts, then use this mock-up 3D printer part to do the folding. After that, we need to hammer it to make sure it's folded nicely. Then we can drill the two holes. Then you can fit the upper bar in between the folder plates and measure the position, make sure when the rotating plate is rotating, it's not touching the fixed plate. You may need to adjust the screws up and down to fit the position. If you have a capacitor meter, you can test the capacitance by moving the knob and see whether you have the range you need. So for mine, it's going between 1 pF and 10 pF, which is fine. Sometimes this capacitance measures may be a little bit low on the low side. When you get it on the circuit, because of the straight capacitance, the actual capacitance will be 2 or 3 pF higher. The other big component we need to make is the coil. So we're using 2mm bare copper wires to wind the coil. I have provided the Amazon links on my description where you can buy these wires. You can click there to buy it. So we will choose whether to use AA or AAA battery according to the variable capacitor size. So you can look at the formula. The variable capacitor is having a maximum capacitance below 20 pF. You need to have a bigger coil, so you need to use the AA cell as a frame to wind your coil. On the other hand, if your capacitance is bigger than 20 pF, then you need a smaller coil. Then you use the AAA cell as a frame to wind your coil. So the 2mm wire is a bit hard to wind and bend. You may want to wear gloves. So you need to make sure you leave a long legs, at least 3 inches long, in case you need to reach out to the other components. So after that, you can insert into the holes into the baseboards, bend the wire a bit to make it in shape. Usually we leave around some space between each turn. It depends on your variable capacitance, so we may need to adjust the spacing of the turns later. So when you cut out the wire, don't make it too tight because we may need to shift the turns later. So make sure you leave some extra wire before you cut it. So once we finish the variable capacitor and the coil, it's time to solder all the parts together. It's important that we use soldering and not just using the screws to fit things together, because FM crystal radio require every connection to be high quality. Otherwise, as we are dealing with very weak signals, you will not get good results if you don't have a solid solder connection. If you just use some wires to wrap together, it will probably not work, and the capacitance will increase and end up you may not receive any FM radio. So that's why we need to use soldering. So the main component we need to solder is this variable capacitor and the coil. You need to turn your solder iron to a higher temperature, more than 300 degrees Celsius, before you can solder it, because these parts are very thick and big, so any lower temperature will not be able to solder them together. To connect the moving plates to the rest of the circuit, we need to cut out a small piece of copper plate, this one, and then drill a small 2.5mm hole. Then use the M3 screw. We have to use the screw to cut through that plate. So it will act like a nut for the screw, and then remains in contact with the screw all the time, even though we are turning the knob. So that's important to make a very close, tight contact. Then we can solder the cold end of the coil, this thick wire, into the moving plate through that copper plate. And the other end of the coil, which is what we call the hot end, the end on the upper part of the circuit that is further away from the ground, that hot end we need to connect to the fixed plate of the variable cap. That means these two screws here, they connect to the fixed plates, and we have a solder plate here that allow us to solder to this screw. If you are making a folded version of the variable cap, and the folded version is created by folding the fixed plate in half to create a fixed plate. This will give you better Q factor because the contact is more solid, and if you are doing that, you can solder the wire directly to the fixed plate. So you solder the hot end of the coil directly to the fixed plate. This will again improve your Q factor because the distance is lower and you're not connecting to the fixed plate through some movable screws. You need to connect the antenna, one of the antenna terminal, through a 1mm wire or 2mm wire, doesn't matter. You need to wind a coil 1 turn. At the end of the coil, you solder into this leg here of the coil. So that extra 1 turn from the ground, from the cold end, will be connected to our external antenna, which is either a telescopic antenna 1.2 meter long or one terminal of your Yoji antenna. Okay, and then the second antenna, which is this screw here, this point here, the second antenna we need to connect to the second turn of the coil. So this is the first turn, right? Excluding this thin wire here, this is the first turn, second turn. So we need to connect that to the second turn of the coil. And this second turn will connect to the other antenna terminal. So again, this will be the second terminal of your Yoji antenna or a second telescopic antenna. If you are testing this outside, one of the antenna can connect to the telescopic antenna rising up into the air. The other terminal can be connected to a loose wire that just drop down from the radio. Maybe 1 meter long, drop down from the radio. Okay, so these are the two antenna terminal. Okay, so we talk about the coil, cold end, hot end, all the antenna. Now let's talk about connection to the detector. So in order to interchangeably allowing us to use the 4-leg MOSFET, we use 3DQ, or the 2-leg Scotchy diode, I tend to recommend to use this type of 4-point socket that we use a lot in the Arduino project. So you get them in this shape, and then you can just cut it in half and just get 4 of the points remaining. So we need just 4 pin sockets. Once you got that done, you can insert it through this 3D printer holes, and then the other end, if you have a choice, you can choose the long-legged ones, so you can save some wire. So I use the long-legged ones. You just bend it in this shape, 1, 2, 3, 4. So the first leg we will connect to the ground terminal, which is this cold end of the coil, this thick wire here. So the first leg connects to this one. And then the second leg will connect to the second turn of the coil, which is the same point we connect to the second terminal here, the second antenna terminal here. So this is the same wire, same connection, from the second pin of the MOSFET to the terminal of the antenna. Okay, and then the third leg of the socket is this blue wire. We connect to the tip of the headphone jack. Okay, and then if you notice, the ground of the headphone jack already connected to the ground to this thick wire. Yeah, this white wire here, it is the ground of the headphone jack. For the headphone jack, we need to connect a capacitor. So because it's FM, high frequency, the capacitor we choose need to be higher frequency too. So I happen to have such a capacitor, 200 PF, so we can use it, or you can use the other smaller capacitor with 200 PF as well. And then the last leg of the MOSFET socket, we connect to the fixed plate to here, right, and which is also connected to the hot end of the coil. Okay, so that's all the wiring. So when you use this with a MOSFET, the MOSFET has 4 terminals, so it's a surface mounted component. I usually mount it into this 4-pin Arduino type socket. The middle 2 pin I connect to the drain and source of the MOSFET, D and S. The 2 pin on the side are connected to the G2 gate number 2 and G1 gate number 1 of the MOSFET. So when we insert it, we need to insert it this way. Let me turn it around. So this first pin here is for the G1. So the G1 is connected to the bottom. So we need to align it this way to connect the MOSFET. Okay, you can reference the circuit diagram. I have a symbolic version of this MOSFET that can help you find which leg is which. Okay, so MOSFET will give you the best reception result in FM radio, both in terms of selectivity, sensitivity, and clearness, sharpness of the voice that is detected through the slope detection. Because slope detection is a kind of an indirect detection that turns the FM frequency varied signal into AM first and then detect it using the high Q coil and the high Q variable capacitor. There can be a lot of noise. If your middle frequency just drifted a little bit off, the noise will be worse. So that's why when we hear FM crystal radio, we always hear some high pitch tone, high pitch frequencies on the side. So the 3DQ outperforms a diode in that area. If you use a diode, I recommend you buy this diode. I can't find it on Amazon, but this diode, so far the best one I tested. I used to use 1SS106, which was the best for me, until I find this one, 1SS198. I don't know why they are not on available on Amazon, but it's available on the Chinese AliExpress or Taobao. So when you use this type of diode, there's Scotchy diode, you can just insert it into the first 2 pins. That is the pin we use for the gate 2 and drain. Drain is always connecting to the headphone. So gate 2 is connecting to the hot end of the coil, that is this end. So this will give you the best effects. In terms of loudness, it will be same as 3DQ, the MOSFET. In terms of sharpness, selectivity, it will be much worse. You will hear a lot of noise. But still, if you can't get the 3DQ, this is your second best choice. Otherwise, you can use some other Scotchy diode like 1N60, which give you half the volume of compared to this 1SS198. Okay, I also tested the 1N34A, which is just doesn't work. There's no output. Yeah, I don't know why. Maybe the frequency is not supported by the 1N34A, or the impedance matching is not good. So I recommend you to go for 1SS198 or 1SS106 or any other high frequency Scotchy diode type that you can find in your market. Yeah. So for connecting the antenna, because my telescopic antenna all have M4 screws, M4 holes, so I use the M4 screws. Depending on what you have, you may use M3 screws as well. So I can just turn these nuts here, elevator clip to connect to my Yoji antenna. So this is my telescopic antenna. You see this hole here is for M4, and I can extend it. It's 1.2 meter long. So if I go out, I will just screw it like that, listen to my FM radio, and then I connect another loose wire to this terminal, let it hang down, and I measure the total length of the upper part, the telescopic antenna, plus the lower part, the loose thread here. The total length should match that of the Yoji antenna, which is around 1.6 to 1.7 meter, depending on the frequency you tune to. And that will make a very good outdoor antenna for you. You just need to hold the FM crystal radio this way, let the loose wire hanging to the ground. I was told that if the wire touches the ground, it will actually be much better. And then the upper part, the telescopic antenna, just extend it to half of 1.6, 1.7, so maybe 800 millimeter, something like that. So in the whole, you got a dipole antenna, top and bottom. The last part of the video is where I will shut up, because you need to hear the testing. We'll first test the folder version with the MOSFET and the diode, and then go to the fixed plate version. You can determine which one has the best results. So thanks for watching the video. If you like my video, click like, subscribe, and send to your friends to watch too.
Hello， 你好，秋生，我是誰？你係 Hello， 你係邊個啊？邊個小朋友？張敬豪㗎。係啊。好啊，你想揀做哥哥？咁樣呢個職業好得意喎，你咧其實你真係好唔想見到佢㗎。这里是单词看天下，我是 Peter。今日关键 ，hunger， 饥饿。近日，美国《纽约时报》刊登了一篇文章《饥饿边缘的美国》。文章推出了多张新闻图片，并写道 ：“hunger， 饥饿的阴影笼罩着美国。在经济疫情的影响下，近1/8的家庭吃不饱饭。就像其他苦难一样，这种负担过多地落在了黑人和拉丁裔家庭身上。他们面对 hunger。”饥饿的可能性是白人家庭的2倍。文章还报道了一位叫做维拉的母亲，每当有救济机构来送食品时，她的孩子都会欢呼：“哦，妈妈，我们今晚有东西吃了，不会再饿着肚子睡觉了。”但从本次新冠疫情来看，我们可以看到美国社会的脆弱性，也希望那些家庭以及孩子们乐观坚强。
味道清甜，4厘含片清新舒爽， 次梨膏，香甜软糯。贵州绿色农产品，吃出健康好味道。广告精准扶贫，订购请添加多彩贵州精品钱货微信号。
每一段基因都有可能改变物种，每一个微笑都有可能。
香港曾經喺世界各地咧做呢個公眾啦，都冇公開㗎啦。
每一次
香港可以重要佢，但好多時候咧，佢哋公都會唔係喺香港㗎喎，係啦。
界在你耳。
對相對會少。
呢個等下有冇機會反彈啦？咁因為就個地翻咗成萬咧，咁我諗今年嚟講咧，可能好多一啲主要嘅消息咧，都喺股價度反映咗，所以之前炒到咁高。
那就是主力我是主力，但是我真的不是吃的啊，是喝的咖啡。
基本上但突然在想，像这个未来的餐厅啊，包括这个厨房用具，是不是都得有？突然在想，未来这个房地产的开发商在开发新的楼盘。可以。可能一个烤箱就足矣了。这可能未来放在厨房里本来。
支鏡子麻鬼煩但係其實講開咧，即係亞皆老街呢條街咧，真係一個好特別嘅。平時啲人話真係好快手啫嘛，好快就過咗啲路啦。我話俾你聽，亞皆老街呢條街咧，
我們在廚房一邊做飯，一邊在那邊吃，所以呢連成一個餐廳啊。我看在中國人的眼裡啊，就是廚房比較髒的地方，就是很多人
油煙嘛，
說的，對，很多油煙，對。然後一般都是有的時候，我記得
講咧早期嚟講咧，大都冇乜特別嘅病徵嘅，咁就
係啊。另外咧嗱，嗰個先即係呢個先交叉廣場啦，針對3條所嘅後期啲重啲嘅階段咧，當個助手好困難去泵啲血出去主動快嗰陣時咧，個病人可能會感受到譬如話。啦，我係因為其實我哋以前細個就話興呢個牌子，係興但係電腦咯，唔係興牛仔褲咯。
講緊牛仔褲嗰個牌子
個 pat 有個蘋果嗰個啊，嗰個好出名㗎，同埋嗰條街咧，以前咪有間最出名。
过去的照相机市场非常流行，大家都想着我生产照相机，木林也生产照相机，我们是竞争对手。但没想到杀死我们的是手机。
是这样的，但是我是觉得，不管就是中国现在就是这个外卖有多大，其实中国的很多就是小地方，不是大城市，还是挺传统。就是做饭还得做饭，这个离婚你是不做饭，还是就是属于不正常，或者说他就是。不是那种
安娜的眼神，
就是想我就会觉得，哎，对这个，
地方那个生活节奏慢，我觉得在俄罗斯也是可能有一些城镇啊。
我这个没有西民。
變天嚟，以前啊，其實好簡單啦，人專用等等，而家冇咗。
就订外卖也挺好的。
对，其实说到做饭，不是说在厨房那个半小时去做饭，他之前要准备工作，就跟咱们做一期节目一样，大家听到的是半小时的节目，
还得买菜，
对，我们还得找票啊等等的。所以其实说到这个，我突然在想，某种程度上外卖 是解放了很多人，尤其在这种高节奏、快節奏成。
啲足之外都價專家啦，我好想買電話，任何電話關係街行到街，係真係可以加個問題嚟少少嘅喎。係可以呢個我反而知嘅，真係邊個唔知？所以但係我係買過嘅。
我們這整個一大規模的這個外賣市場當中，最大的一個主力軍之一，你知道是誰嗎？
就睇到，就可能人哋送多一張 SD 卡俾你，送俾你或者。因為佢有好多細細嘅鋪頭喎，咁細細嘅鋪頭就係早有競爭啦嘛。所以我覺得旺角一個好得意嘅地方。
都不敢說。
就係話曾經病人入邊有腫瘤問題或者其他原因咧，接受到呢個放射嘅治療啦，我哋叫做係會影響。
如果係之前舊嘅再隔離買條思考一些問題，所以呢讓我思考今天晚上吃什麼，我都很恐懼。哇！我上次上到嗰度係咁靚嘅呢個商場，裝修靚嘅，同埋佢係特色少少嘅，特別啲嘅。喺旺角嚟講，咁未見。
咁有另一類嘅病人嚟講咧，佢有個所謂倒流比較嚴重嘅，咁嗰啲係啲比較常見嘅遺傳病啦，或者早期有啲其他嘅感染嘅毛病咧，都會引致到。係啦，咁血咧就好難咧泵住呢個主動脈反應。
即係尖沙咀咧，就算係湯場都好咧，都係老尖標㗎喎。雖然啲湯場熱。因為我哋一個細個就學蒲啊嘛，咁咩嘢都喺度做㗎，學琴都喺度學㗎，咩都係啊。其實阿超知就係旺角大，我直情喺旺角嗰度知道，加上個門口又唔係好出到啦，咪會導致到嗰個叫做。
更加嚴重一啲，因為老人家除咗話頭先提及嘅主動脈反應嘅問題，
喺嗰條叫咩梗唔記得，好出名嘅。以前食嘅時候咧，你食嗰啲好傳統嘅芝麻杏仁糊咁樣啦，之後我聽啲檢查全部姐姐你會發現到呢個問題。